Hello and welcome everyone. This is Manish from Skill Level India, and today we are going to start our new series on geometric dimensioning and tolerancing. So this series actually this is the part of product design and development master program. Okay, so this is in the continuation. So this actual Gd&t, we will be covering all the topics of geometric dimensioning and tolerancing from the basics. Okay, so at the beginner level, if you are a GD or if you are a student, so I'm going to cover all the topics from the beginning. Okay, so you don't have to worry about that it is a very complex topic, which is geometric dimensioning and tolerancing. So don't worry about it. We are going to cover it from the beginning. Okay, so I'm also letting you know some engineering terminologies because students gets confused. Okay, that what are datums, what are features, if I'm talking about feature of size. Okay, so there are a lot of definitions in that, so you don't have to worry. I am going to cover each and everything from the basics, and then we will go towards the intermediate, where we will be learning some usage of or how to implement Gd&t into the engineering drawings. Okay, and then I will take you from the towards the advanced level. In that, you will be particularly understanding that how to apply Gd&t and in which cases. Okay, so some of the case studies I am going to cover, and in those case studies, definitely I will be telling you most of the usage. Let's say position or under the location control. Okay, so multiple things we will be covering in this particular course. Okay, so this is the just an overview of the geometric dimensioning and tolerancing. Now I'm going to start with the fundamentals of geometric dimensioning and tolerancing. In that, I'm going to cover I will say the history, the brief history. I will tell that where actually the geometric dimensioning and tolerancing has been originated. Okay, has been introduced. What are the conditions when the problem came into existence, and the engineers who have developed Gd&t and give this solution to overcome that problem. Okay, so I will be letting you know towards that problem also, and in the next part of that of the video of the fundamental of Gd&t, I will be letting you know all the topics which we are going to cover in this particular course. Okay, so stay with us. Okay, so now we are going to start our course on geometric dimensioning and tolerancing. Season is not a choice, it's a necessity. Hi, this is Manish Sharma, and in today's session, we are going to start with the fundamental of Gd&t. Okay, so what is geometric dimensioning and tolerancing? Why we are going to use this Gd&t, and what's the need of using Gd&t? Okay, so we are going to I'm going to cover this course of geometric dimensioning and tolerancing from the basics. Okay, all the topics which students don't know about. Okay, so I am not considering that you are a working professional and you know the basics. I am covering this course from the basics, that I will be telling you that what are datums, what are feature of sizes, what are limit of size, limit of tolerance. Okay, so all those things I am going to discuss with you in this course of geometric dimensioning and tolerancing. As I have already told you that this is the continuation of product design and development. Okay, so this is the continuation part. So in this particular course, you will be connecting a lot of things which we have already discussed. Okay, so I have already told you that manufacturing or engineering drawings, that manufacturing drawings are very, very important document. Actually, they communicate the part requirement precisely. Okay, that precision, in the starting I have told precision is not a choice, it's a necessity. Okay, whenever we are going to manufacture any part or any component which we are going to manufacture, so to control all the sizes and the shape, form, orientation, and all the related things into that part, we use geometric dimensioning and tolerancing. Okay, if I write it down over here, one of the important note. Okay, so to define the size, shape, or relationship between the relationship between the surfaces, or we can say features surfaces and total allowable variation and total allowable variation in a part, we use geometric dimensioning and tolerancing. So this is a very important thing which we need to take into account, that why we are using the geometric dimensioning and tolerancing. Okay. So in this particular session, first of all, we will understand that what are the standards we are going to discuss in this particular course. Okay. So we are going to discuss about the ASME standards, although there are lot of standards around using around the world. Okay. But why we are understanding about more, why we are focusing more about these standards, I will let you know that what specific topics we are going to discuss in this particular session. Okay. So first I'm going to erase this. So what are the different standards used are all around the world? First of all, there are ASME standard. Okay. So what standard we are going to understand is of ASME. ASME by 14.5 2018. Okay. So ASME stand for American Society of Mechanical Engineers. Okay. So this is the organization, or this is the standard organization which has provided the standard, which is by 14.5. Okay. So by 14.5 is the standard. And 2018 is the year updated, the latest update which comes into the year is 2018. So the latest update we got in 2018. Okay. Although ASME has previous standard, ASME by 14.5 2009 standard. Okay. I will tell you that what are the differences between the 2009 standard and 2018 standard. That there are two geometric characteristics which are symmetry and concentricity, which are being removed in 2018, but they are till 2018 as per the 2009 standard, we are using those geometric characteristics. So I will also let you know that why in the recent standard those characteristics are being removed. Okay. So one by one all those things we are going to discuss. And other than the ASME standards, there are ISO standards, there are JIS standard, which are the Japanese standard, there are BIS standard. Okay, so there are a lot of other standards are also there, but as per the organizations which are using right now, okay, so 90% of the companies which I have seen are using the ASME standard. Why they are using? Because their standard is more practical in nature. Okay. And what ISO standards are more theoretical one. Okay. So more from the practical aspect, if we see, so ASME has given some practical scenarios, okay, to understand these standards better. Okay. So that's why we are going to learn about ASME standards. Okay. So particularly, first of all, I will give you an overview, and I will tell you some of the brief history of geometric dimensioning and tolerancing, that why there is a need of using the Gd&t. Okay, so the first question arises in front of us, that when the concept is being generated, the concept of Gd&t or the geometric dimensioning and tolerancing was introduced by Stanley Parker. Okay, so Stanley Parker is from the Scotland, and this concept he has made in the late 1930s after the Second World War. Okay, so what problems he has faced into the Second World War? He was actually an engineer in the munition department under Britain. Okay, so there are a lot of armor manufacturing at the time of World War. Okay, so at that manufacturing time, there are a lot of assemblies are going to be done. Okay, but as the time of inspection, the lot of parts are being rejected. Okay, so he was working in a munition under Britain. Torpedoes and other ammunition parts were rejected when inspected using a traditional tolerance system. Okay, so whenever we are using the traditional tolerance system, a lot of parts at that time are going to be rejected, okay, under the inspection. So in 1938, he developed the concept of position. Okay, so only he has started with the location control, which comes under the position or the true positional tolerance. Okay, during World War II, companies had to outsource part because of the large quantities and tight schedule. Okay, so that's why they are manufacturing at a lot. I will say lakhs of parts they are manufacturing and they are assembling with one another. Okay, so the problem is many parts are getting rejected because of the tighter tolerances. Okay, because of the coordinate tolerance system. So why the coordinate tolerance system have less tolerance zone, less than the geometric dimensioning and tolerancing. So all those discussions we will be doing further. So that's the problem. This is the very big problem, that part are not getting assembled with each other, and if they are not assembled, their functionality will affect. Okay, so the function which is intended, the part which is intended to function, it is not performing the required function. So that's why the part, either the part is going to be rework. Okay, so the rework has been done onto the same part, or it is going to be scrap. Okay, so to reduce the overall rejection, or to reduce the scrap rate, or to reduce the rework, the concept of geometric dimensioning and tolerancing comes into action. Okay, so this is the brief history, and now we are going to understand that what is Gd&t is all about. So geometric dimensioning and tolerancing is a symbolic language. Okay, so first of all, we need to understand from the basic, it's just a symbolic language in which we are going to use one feature control frame. Okay, in that feature control frame, there are multiple compartments, or in those compartments, we are going to write it down. I will be telling each and every compartment that how we fill those compartments. Okay, so first of all, geometric dimensioning and tolerancing is symbolic language, which communicates the part, intent and function through design, manufacturing and inspection. Okay, so actually that engineering drawing which we are incorporating the Gd&t into it, so the it communicates the part intent through design, through manufacturing and inspection. Okay, so all the stages will be in the same loop with the help of that engineering drawing, which consists of Gd&t standards. It also gives more precise depiction of the part feature. Why it is going to give the more precise depiction? Because we are going to get more control over it. Okay, it controls form, orientation, location, profile and runout. Okay, so the 5 categories in the Gd&t, there are 5 categories. Form, which is saying about the shape. Okay, then there is orientation, we are talking about angles. Location, profile and runout. There are 5 categories. Okay, so one by one I will let you know that how these categories are being subdivided. Okay, and how many characteristics are there. Okay, it also focuses on feature to feature relationship. Okay, so Gd&t focuses on feature to feature relationship. Since Gd&t is expressed using line drawings, symbols and Arabic numerals in feature control frame, people all over the world can read, write and understand regardless of their native language. Okay, so this Gd&t is not dependent on one country or one region. We all these standards are applicable for all around the world. Okay, so these are very, very helpful, and this is what is Gd&t. Okay, these are the definition for the what is Gd&t. Now, with one example, I will let you know that how we are going to understand the concept of Gd&t and why there is a need. Okay, so in this example, you can see that I'm going to give an overview with this just. Okay, to understand the Gd&t concept, let us take a small example. Right now, you can see an image over here. Okay, this is a rectangle or a rectangular block. Okay, so if somebody wants to manufacture the part, okay, so we have to provide some dimensions to this part. Okay, so but with this manufacturing, is not possible. Okay, just by showing this rectangle, the manufacturing is not possible. Okay, so to produce this part, we have to give some dimensions to this part. Okay, so in this you can see that I have given some sizes or the dimensions into this. So what we do is we have added the dimension and dimensional tolerances. Okay, so here you can see 100 plus minus 0.1 and 50 plus minus 0.1. Okay, so dimension and dimensional tolerances we have added when only limit of size is given. Okay, so when only limit of size is given, then we may end up producing a part like this. Okay, you can see only limit of sizes are given. Limit of size. Okay, so when only limit of size is given, okay, so with the help of that we can produce a part like this. Okay, this is one possibility, that the part can be produced like this. In this you can see, if we will see that the upper limit is here is 100.1 and the lower limit is 99.9. Okay, so upper limit minus lower limit 0.2 mm is the dimensional tolerance. Okay, so this is the possibility. This is the first possibility. The second possibility is where the dimension are limit, but the surface is not accurate. In this you can see the dimensions are within the limit. All the dimensions are within the limit, but the surface is not accurate. Okay, so here the problem is surface is not accurate. Surface is not accurate. Okay, so there will be, in this you can see there is a form error. So there is a form error. So this is one possibility. The other possibility is the part can be another possibility is we may end up creating a part like this also. Okay, so in this case you can see that all actual local size. Okay, so actual local size, if I'm measuring from here to here or I'm measuring from here to here. Okay, so actual local size is within the limit of size. Okay, so I'm writing now note over here. In this example, actual local size is within the limit of size. Within the limit of size. Okay, so wherever we measure, we are measuring from here to here or here to here. Okay, so actual local size is within the limit of size. Okay, but there is a bend error, bend in the part. You can see there is a bend into the part. Okay, so this is one of the major problem, that although this is under the actual local size is within the limit of size, but there is a bend error. Okay, if this part is going to be assembled with the mating part, that what type of problem we are going to face. Okay, so when we produce a part like this and try to assemble with the mating part, okay, through the part within the limit of size, it will not enter properly. Okay, so the problem will occur, it will not enter properly. It will not enter properly, okay, in the mating part. So thus in all such cases, what we do is we have to use the geometric dimensioning and tolerancing, okay, to control the shape also. Okay, not only we are controlling with the help of Gd&t, with the help of Gd&t, we are controlling the size and the shape of the part. Okay, so here you can see shape is also very important. Okay, because we have seen in this example, because all actual local size are accurate, but there is a bend into the part. Okay, so to control this bend also, okay, so to control this bend we have to use the Gd&t. Okay, now it conveys both the nominal dimension. In this example, now we will understand that how many controls are there how many categories are there. Okay, so all those categories we will understand this one by one. So first category you can see over here is for individual features. Okay, so first of all we will the geometric characteristic symbols. Okay, so there are these are the geometric symbols which are in 2009 standard, you can see. Okay, these are into the 2009 standard. You can see 2009 over here, and this is as per the 2018 standard. Okay, so first of all we will see that there are three categories for individual feature, for individual feature, okay, for related feature. So as we are moving towards the geometric characteristic symbols, okay, so as per the ASME by 14.5 2009 standard, there are almost 14 geometric characteristic symbols. Okay, so there are total 14 geometric characteristic symbol as per ASME by 14.5 2009 standard. Okay, but in the latest update, as I have told you, in the 2018 standard, two of the geometric characteristic symbols are being removed, which are as per the 2018 standard, two standards are being removed, which are concentricity and symmetry. Okay, I will let you know that why they have removed in the further sessions. Okay, so do not confuse in this. Just for your knowledge, I'm telling you this thing, that the latest standard which has been released of ASME by 14.5 is in 2018. Okay, I have already told you in Gd&t we have totally 14 symbols, and they are broadly classified in three categories. Okay, so the first category is individual feature. The first category which is divided is individual feature. Individual features are the features which does not depends on the neighboring feature. Okay, so what are individual features? Which does not depend on the neighboring features. Okay, so those are called individual feature. Under this individual feature, you can see there is one type of tolerances which is under we have the form control. Okay, so under the individual feature we have form control. In this form control we have straightness, flatness, circularity, and cylindricity. Okay, so these four geometric characteristics we have under form control in the type of tolerances. Okay, the second classification in this we have is for the individual feature or the related feature. Okay, so this is for both individual as well as for related feature. Okay, under individual and related feature only one type of tolerance comes, okay, which is profile. Okay, so in profile we have profile of a line and profile of a surface. Okay, so this feature are what is individual or related feature? So these features are the features which require relationship or dependencies with the neighboring part sometimes. Okay, so they are dependent or sometimes they are not dependent. Okay, so these features are in both the cases we use this type of tolerances, or we use this category. Okay, the third category what we have is here is, you can see the third category what we have is related feature. Okay, so what is this related feature? These are the features which are always dependent on the neighboring feature. Related feature is the feature which are always dependent on the neighboring feature. Okay, under related feature we have three subcategories. Okay, first subcategory is orientation. Whenever the relationship between the feature or angle, okay, whenever the relationship between the feature or angle, we called it a orientation. Okay, so whenever we are talking about angles, okay, relation between the feature or angle, so we are considering that we called it as orientation control. Okay, now under which we have angularity, we have perpendicularity, and we have parallelism. So under orientation, we have three characteristics. First is angularity, perpendicularity, and third is parallelism. Okay. The next subcategory is called the location control. Okay. So the next subcategory under the related feature is the location control, under which we have, you can see we have three over here: position, concentricity, and symmetry. Okay. So under location control, we have three geometric characteristics: position, concentricity, and symmetry, as per the ASME Y 14.5 2009 standard. Okay. Now the third subcategory which we have over here is of runout. Okay. So the next subcategory is runout. Under runout we have circular runout and total runout. Okay. So all put together, we have 14 geometric characteristic symbol as per ASME Y 14.5 2009 standard. Okay. Under orientation, you can see angularity is an alternate practice of perpendicularity and parallelism. Okay. So we use angularity for perpendicularity and parallelism. For both of these, we use angularity only. Okay. And when it comes to ASME Y 14.5 2018 standard, the concentricity and symmetry are being removed. So we have only position left. Okay. Position control under the location. So we have left with only position under location control. I will let you know one by one when we will be discussing each and every geometric characteristics, that how we can use this geometric characteristics. At that time, I will let you know that why symmetry and concentricity are being removed, and while removing, why we are using position in terms why we are using the position under location control in terms of the symmetry and concentricity. Okay. To get the full advantage of these geometric characteristic symbol, we have something called modifiers also. Okay. So what are these modifiers? I will be letting you know one by one that how we use these modifiers. Okay. So when we use these modifiers along with the geometric characteristic symbols, we will get more advantage of the tolerances. Okay. So we get more and more advantage of tolerances. That's why we use these modifier with the geometric characteristics symbol. Okay. So here you can see over here to follow, you can see in this particular image that we have their maximum material condition, least material condition, and these are the symbols. Okay. So we are going to discuss each and every symbol in the coming session. So do not confuse in that. This is translational, projected tolerance zone, free state. Okay. So for by we use free state. So I will be telling you the concept of free state, that in which conditions we use for free state. Okay. Then there is a tangent plane, unequally disposed profile, independency, and all these modifiers which we use into our manufacturing drawings. Okay. So these are the very, very important one which we are discussing over here. Now, in the next part, now we are going to discuss the course topics which we are going to discuss in this whole course. Okay. So these are some of the these are all the topics which I am writing down over here, that what we are going to discuss in the coming sessions. Okay. So we are starting with the introduction to Gd&t. Then we are going to cover the 16 fundamental rules of engineering drawing, which is a very, very important concept for the design engineers. Not only the design engineers, because the 70% to 80% control is in the hand of design team. Okay. So that's why you as a design engineer, if you want to become a design engineer, or you want to make your career as a design engineer, then you have to remember that these fundamental rules are very, very important. Okay. Into your engineering drawings. While making your engineering drawings, you have to use these fundamental rules, and it will become very, very easy for you to use. Okay. So whenever I say ASME by 14.5 2018 standard or 2009 standard, if the drawing is applicable as per those standards, these fundamental rules, these 16 fundamental rules will automatically apply. Okay. Then there is a dimensional and tolerances, coordinate tolerance system, what are feature of size, actual meeting envelope, unrelated actual meeting envelope, related actual meeting envelope, actual minimum material envelope, unrelated and related actual minimum material envelope, what are material modifiers, what is RFS regardless of feature of size, okay, versus maximum material condition versus least material condition. Okay, what is rule 1 and rule 2, datum, planes, constraint, relationship, what are bonus tolerances, what is tolerance diagram, how we can calculate with the help of tolerance diagram a bonus tolerance. Okay, what is a virtual condition, what is a resultant condition, what is feature control frame, what is controlled radius. So these are the topics which we are going to discuss in this course. Okay, then there are other topics also, like straightness. These are the geometric characteristics, symbols, characteristics which we will be discussing one by one. We are also going to discuss what is datum, what are datum reference frame, okay, what is 3-to-1 principle, and how we can apply 3-to-1 principle with the help of degree of freedom. Okay, so we will understand the whole concept of degree of freedom also in this. We are also going to understand about floating and fixed fastener, okay, and many more other topics. Okay, so these are some of the topics which we are going to discuss in the coming sessions of this course, and each and every session is connected with other session. So do not skip any session, and the assignments and the quizzes what I am going to give in this course. So although complete one by one, if you have seen this lecture, so you have to complete the assignment and the quiz, because if you will complete, you will have more and more confidence of learning. Okay, because Gd&t's concepts are very, very important, and the document or the PDF file what I am going to share with you, go through all the points. Okay, so learn all the points, because those are the points which are very, very necessary to know about. Okay, so that's why. So this is all for this session. This is the introductory session. So I have tried to cover all the basic things of this. Okay, from the next session, I will be more covering the related topic to the geometric dimensioning and tolerancing. Thank you everyone.